Okay, welcome back. In like 40 minutes, end up doing like 3 lessons. Hopefully these will be helpful for you. Lesson 10.2 now is all. I'm also going to split that into 2 parts. I think they're smaller parts than lesson 10.1 for Algebra 2. But now we're going to be transforming sine, cosine, and tangent graphs. And where this all comes from, where a sine, cosine, and tangent graph comes from, is basically the unit circle that we just talked about, and then taking that unit circle and actually rolling it. If I was able to put a stylus right here and roll it, this is the shape that it would actually make on any of these spots. If I start down here and I start rolling it, it would go up and then it would come back down, and it would go down here and then it would come back up when it would rotate a full 360 or 2 pi. If I just do 1 pi, again, remember, this is 30, that's 60, that's 90, that's 30, that's 60, that's 90 in the next quadrant. So another 30, another 30, another 30. Each of these pi over 6, 2, and 3s are basically 1/6 of pi apart. Well, 1/6 of 180 is 30 degrees apart. Okay, it's just, I remember I read a book about a guy who was growing up. He came to America from Mexico and was put into a Catholic school, and the nuns forced him to speak English. And at the beginning, he was translating back and forth. It's like, okay, baño means bathroom, baño means bathroom, uno means one, and all those different things. He was translating. Eventually, he got to the point where because he wasn't speaking Spanish anymore, he ended up forgetting Spanish. Now, I don't want you to forget Spanish if you're a Spanish speaker. I also don't want you to forget degrees, because you'll use both of them purposefully. Okay, this is more of an applied, and this is more of a theoretical. Once you've done all the theoretical, you can switch it back to degrees, and it's much smaller numbers and much easier to deal with that way. Okay, but this is more real life, because you're not doing anything more than 360 degrees in life. You're not doing 2 pi over 7 for a garden. You're doing, whatever that is in degrees. All right, so that's really where this comes from. And if we're talking about the sine of it, sine is going to start down here. It's going to go down and up. There's the sine graph. Cosine, okay, would actually start up here, because cosine is at 1. Cosine would start up here, and it would go down to here, and it would come down to here, and it would come back up, and then it would, and you'll see that as we get there. I think that's the next screen even. So let's go to that next screen. And there they are. There's the graphs of sine and cosine. And I wrote over the top of them right here. I made sure that what I could do is use this to shift, not the graph, but the line. There we go. Let's shift just the line. I just want to shift the line. Anyway, you can see if I'm shifting the line, I can shift it. And what ends up happening actually is that, if you'll notice, that cosine is really, if I shifted cosine over 90 degrees or pi over 2, it's the same graph. If I took this cosine and I moved it up here, you can see how it's the same thing as the sine graph if I just move it over 90 degrees, okay, or pi over 2. Okay, so you could look at a graph and say, oh, that's sine. No, it's cosine plus 9 or plus 90 or plus pi over 2. That ends up being the same actual graph. Now, you're not going to need that for any of the questions you're going to get this year, but it's kind of cool to play with when you're in pre-calculus. So that's what, again, the cosine starts up here. Cosine starts at 1, because remember, on the unit circle, it's over here at 1. And sine up and down goes 0. That's why it starts at 0. And it rolls, as it rolls up, it goes up to 1, goes back to 0, down to -1, and then back up to 0. All right, tangent is a different one. It's a little bit quirkier, all right? And so tangent ends up looking like this. It ends up looking like the S-curves, if they were flipped on their side. The inverse of the S-curves is this, okay? So you're going left and right, or right then left, and right then left, and right then left, and it repeats itself over and over and over again. Over that same time, the same thing actually happens with sine, and I'll draw the sine right now. Sine actually would look like this. Whoops, it's not doing it. There we go. Sine would look like, oh, sheesh. Let's undo that. There we go. I'm putting sine right here. Sine goes up to 1 at pi over 2. It's down back to 0 at 180. It's down to 1 at 3 pi over 2, negative 1. And then it's back at 360. Whereas cosine, I'll do it with a different color altogether. Actually, let's use yellow. I think it shows up better on your screen. It starts here at 1, and it dips down to there. It dips down to 1, negative 1 there, comes back up to 0, and then back up. Whoops, I went a little farther. Back up to positive 1. But basically, this is what those graphs would look if I superimpose them on top of each other. All right. So what we're going to do first is we're going to deal with just the midline. Okay, and that is a part of the graph that we'll see. Now, on all of these, if you'll notice, the midline is here at 0. Okay, 1, negative 1, 0. 1, negative 1, 0. Okay, the midline, and that is when I add the midline being up or subtract from the midline being down, that's when we take cosine x and we add 1, or we add 2 to make it go up. Or we subtract 4. And that makes the whole graph go down. Just like we've always done with all of our others. If you have x squared minus 4, it means you take the parabola and you shift it down. Okay? Let's see if I can angle this up a little bit better and get a little bit less glare on that. That's a little bit better. Okay? So, we get a little bit, yeah, I guess if I stand out of the way too, that helps too. So with x squared, if we add a negative 4 at the end, it shifts the whole thing down. If you put a negative 4 here, it shifts the whole thing down. That shifts the midline down. Okay? The coordinate of the midline shifts down if you put a negative 4 in there. So on this one, okay, we want to find out where that goes. And I just hope I can make this thing move the right way. Whoops. Undo, undo, undo. There we go. I don't want that one. I want this one. No, I want that one. Well, I'm going to have to shift it like this. Okay, the midline looks like it's right about there. And we can't see the bottom number anymore, but what we need to do is we'll look at this, and what we'll see is that 5.5, and its entire range goes down here to what looks like, where is it? Yeah, I guess that's about 1.5. So from this is 1.5 up, and another 5.5 up further, which makes it 7. So which means it goes down 3.5, half of that. So there's a half, there's 1.5, 2.5, 3.5. So we shift that whole thing down to 2. And we'll just do it that way for right now. So what is the equation of the midline? The equation of the midline will be, let's shift that back to red. Y equals 2. That's it. That's all we have to do. Okay, shift it so that it goes y equals 2. All right, next one. One of these days I'm going to figure out how to do this a little bit more precisely, but that's okay. All right, now we've got a range of 2.4 up to 13. Well, it starts 2.4 up, so that means I got to subtract it, which makes it 10.6. So I got to drop this down half of that. 10.6. I got to drop it down half of that. Okay? And half of that is going to be 5.8. No, it's 5.3. 5.3. So then we're going to shift this. Maybe I can do this. I'm going to shift it up here to 5.3, right about there. Okay? And let's see if I can do it. I'll try it once, and if I can't, nope. So we're just going to do this. 5.3. Sorry, it goes 5.3 up from that. So that'd be let's see, 7.7. So it actually goes to right there. And that looks like it's about halfway. No, it doesn't. Let's go closer to 8. There we go. And that looks a lot closer to halfway. Okay? All right, we've got the next one. So yeah, I'll put that as y equals 7.7. That's a horrible one. Life goes on, though. Okay, next one. What is the midline equation of the function? Our bottom part is at negative 8.2. And the amplitude, Okay, that's how far up and down it goes, is at 5.4. Now, if you just look at this, you're like, well, wait a minute, is it from here to there is 5.4? Well, this is 8, and then 9, and 10, and some change. So obviously, it can't be just all the way here. The 5.4 basically is going to add to this, which in essence subtracts from the number. So if I take 5 away from that, it becomes 3, but then I got to take another 0.4, which is 2.8. And 2.8 looks like it is like right about there. Okay? And that is about halfway. If I could have drawn that and drug it down there at 2.8, because 5.4 is this 5.4, and then another 5.4 up to here, which is 10.8. And from here, if I go 10.8, I end up at 2.6. Yes, that's right. Got to do those math in your head. So y is equal to negative 2.8. Yes, just wanted to confirm. All right, the graph of this equation has a maximum point and a minimum point. Negative 2.2 and negative 8.5, how far apart are they? They are 6.3 apart. They're 6.3 apart, 6.3. If I cut that in half, I end up with 3.15. Now, what's the midline? Midline is going to be 3.15 from either of these points. So I'm just going to go from this one right here. And if I go 3.15, so I'll just go minus 3.15 from the 2.2, that's going to make it 5.35. So 5.35 looks like it would be, well, that's a little low. Now let's undo that so I can actually do a little bit more accurate. And that's about where it is. And if you look at that, that's about the same distance right there. 5.35. Negative 5.35. All right, next one. Now, there's all these letters. And, we learned about what happened if you put something in front of x squared. And that made, made it go get wider or get skinnier. Okay. This kind of does the same thing. This shifts it left or right. This shifts it up or down. Now, this is the format I want you to look at, because you're going to be given that format, and I show it again in the next video. They usually say D is first, and then A, then B, then C. That doesn't make any sense. Why not go A, B, C, then D? And if it's plus, I can move this all the way over here. I can move it over there. So this is the up and down. This is the left and right, just like we've always been doing. Okay? And this is what's going to shift things. Okay? This is going to change as we look at it. Amplitude. This is the number that is, this number is influenced, but half the range, by half the range. I think it should have by. I'll try and fix that. By half the range from the highest to lowest. Okay? So that 5.4 we saw earlier, that would go right there. That's the amplitude. From the median or midline to the highest point or to the lowest point. What's the absolute value of that number? That's the amplitude. Okay, that's how big and tall we make it. Now the period is how much we stretch it. Okay? And don't forget, 2 pi over b is the same as 360 over b. Now if they give it to you in degrees, you need to use that number when you divide. If they give it to you just in a regular number and there's no degree symbol, then you divide 2 pi by that number. Okay? And it's 2 pi radians or 360 degrees. Assume radians unless there's a degree symbol, which I didn't put on there. I'll make sure I put it on there right there. Make that little dot for the degree symbol. Okay? The C is the shift left or right, horizontal. This uses the Bizarro logic and shifts graphs to the left or right, but opposite of what you'd think. Left is positive and right is negative. Okay? And then the vertical translation, this letter just shifts the whole graph up or down. Okay, the range of the function, okay, how much their range is, you take whatever D is, okay, and you subtract the amplitude. just a little bit of information. We'll look at it a bunch of times. We're not spending as much time on all of it yet, but that was just the introduction. And they're asking, what is the amplitude of the function? From this halfway point at 3.3 up to this one, 9.8. That's 6.5. So our answer is literally 6.5. Because 6.5 plus 3.3 gives me 9.8. And that's it. It's that easy. And so if we were to do that, that's 6.5. Whoops. I went to the wrong one. We got sounds of the ocean. Let's go back to that. There we go. I don't know how I did that. If we go back one, the amplitude we would use right there as 6.5. That would go in front of whatever function we were dealing with, sine, cosine, or tangent. Okay, what is the amplitude of this one? Okay, remember, subtract. You're finding the difference. Okay, this is from all the way up here, because they're both positive, because they're both, on the same side of the x-axis. What ends up happening is this 2.4 raises up to 13, which is what, 10.6? So that distance from top to bottom is 10.6, but the amplitude is half that, which gives us 5.3 units. Okay? The amplitude is an absolute value in this case. It's not going to be plus or minus. All right. What's the amplitude of this function? Well, it's just from this point at negative 3.8 up to positive 3.8. Well, up 3.8, up another 3.8 is just double whatever that is. Okay, don't think that this is a midpoint. Don't think it's a midline. Okay, it just goes up 3.8, up 3.8. That's what, 6.16, which is really 7.6. 7.6 units. Okay, another one. We've got this one down here at negative 8.5. Well, it's got to go, to get to 2.5, it's got to go up 6. And then it's got to go up another 0.3. So this, from here down to there, okay, that's 6.3. Okay, because it went up 0.5 to there, and 1.5, 2.5, 3.5, 4.5, 5.5, and another 0.8 to get to the 0.2. And that 0.8 plus the 5.5 gives us 6.3. We divide that by 2, and we get 3.15 units. I'd prefer 3.14, but that's just how I roll. All right, last one. Below is the graph of trigonometric function. It intersects the midline at 3.7 and at 5.9. Interesting. What is the period of the function? Now, I only have one of these on here, so we're only going to do one. I thought I would have more of them on there. The period is from where it starts to where it completes the entire cycle, and then it starts to repeat itself. So this is really only half the period. And now we're dealing with a horizontal component, so it's an x coordinate. And from 3.7 to 5.9, we've got 2.2. So we've got to have another 2.2, and the period is 4.4 units for the entire period. Okay? 4.4 units. And that's it. So we'll pick up in a few minutes if you're watching these live. Otherwise, have a good day.